Okay, so the one thing that I did last day in between the sessions was I corrected. So I corrected one thing. So essentially we had an extra dimension here, which made no sense, but now it makes sense. And so what I changed is the following. So which I think that now it's exactly what it's the way it's supposed to be, right? So there's one thing is this basically D model tells you what is the dimensionality of each token, right? My assumption here is going to be that we are currently just encoding the characters and that's it, right? Later on, each of these will be modified. That's what we're going to be working today on. So it's going to be modified by the positional encoding. Of course, one could do something else, and one could just add more information in here before we do the positional encoding. Right. So we could also just say to do here or question like to do. Could we improve the encoding even more? For example, say you keep kind of like say 5 dimensions to encode card, like whatever the longest word can be, right? So you keep a certain amount of dimensions just to encode the characters, but then you use other dimensions to kind of encode other things about the specific word. But you need to have this data somehow curated by hand and have a way to kind of have a dictionary of adjectives and stuff like that, and then have a way to just even more data. So have a way to basically add this information, right? So that'll be, but I'll just leave it. I don't really think if it's really a to-do that we need to leave in here, but it just it's kind of okay. So this is one thing. The second thing would be, now we have basically so now you have for each, so this is each token, right? So, and because we are gonna have when we'll do the training, I guess, right, you'll have multiple, you'll be processing sentences as batches. I don't know exactly how it's going to look like yet, but it's definitely going to be more. It's definitely going to be more than one sentence. So of course you want to have because of the whole matrix multiplication stuff, you want to have the length of each sentence to be also the same, and that's where max length comes in, right? So this bit here tokenizes the sequence, and what I'll try to do once this is clean and working, we'll try to do a very reduced example in 2 dimensions maybe, and we will try to plot maybe the kind of vectors, right? Because two-dimensional vectors can easily be plotted. So tokenize the input sequence. The only thing this does is turns into the tokens. It pads the tokens with these zeros, right? So they all have that D. And here I'm using D model, right? Not max length. Then we cast them into NumPy arrays. Exactly, but what we're doing here, that's what we're doing here. This here is we're tokenizing the input sentence, and so what we're doing is we're just saying also that if there is less words than max length, then we're adding like empty words, and these are all. This is this, for example, an all zeros word, right? I don't know. It is also information in a way. If you think about like the way you encode a sentence is by tokenizing the words, and so if you have these empty words, that also is information because it tells you how long or short the sentence is. So far, I'm just gonna keep it to just one element, and we will not add multiple elements. And now let's just see if we can get it to work. Can get the positional encoding to work. Okay, so. This is kind of okay. So we're now here and it all prints well. So you have this sentence, yeah. So this is what it is. Now, what is this supposed to be doing? So this has D model and max length, right? So compute the positional encodings before training. What we want to do. What this is supposed to do is essentially give us. This is my understanding, right? So it adds information to each of these arrays, but it doesn't change the shape or anything, right? So, but let's make sure we can also ask Ghostwriter. So, what's the goal of positional encoding? is it that we are just adding data to the one-hot vectors? Are we changing the shape of our tensor at all? You add sequential information into the input tensor so that the transformer has a sense of sequence of tokens being processed. Positional encodings are added to the one-hot vectors, but not changing the shape of the tensor. Exactly. The positional encoding layer is added on top of the one-hot input sequence, so the shape of the input sequence stays the same. Number of tokens times token dimensions. Exactly. Yeah, exactly. So number of tokens times token dimension. That's what we have. Number of tokens. So this is this 10. It's a 10 by 10. Okay. So can I print the shape? Go to the shape of an NP tensor. Just shape. So we can print the shape as well. So so we're inputting these, and so we're doing let's run these. So this should be a 10 by 10. Exactly. Perfect. And now we're here, so it should stay 10 by 10. So it should only add these, which then makes sense that these are the two input parameters. So first we compute, I guess that's correct, max line D model. And then you're essentially for position in here, for I in here, and then it's calculating something. Can we print these? So print PE, and then also print PE shape. Okay, yes, so that's correct. So it's doing something, which basically this is supposed to be information. I'm gonna assume it's correct. I'm not gonna dig into how this is calculated, but we can maybe do this later. Why the sine and the cosine somehow encode position in here? That is sort of a question for later. So to do. Why does this work well, and what are other options? So the same is going to be for here, right? So now I think the only thing we need to change is this doesn't seem to be okay. So add a batch dimension. Okay, so add a batch dimension to the positional encodings. I'm gonna get rid of these. So far, I don't know why is it doing it, but I don't think this makes sense at all. And what's more, new axis, I don't know why is it doing it like that. So we'll just so we will just do these, right? And then this kind of call is, so the way this is organized is essentially by just saying you create that, and then so this is a positional encoding, and then you apply it to X, right? I have no idea what is these here, so I think this should just be input IDs, to be honest. So self and then X basically, which is the ND array. And so add the position encodings to the input tensor. I don't know if that's the way it's supposed to work, but let's give it a try. It returns X. So let us just print here. X. So we have the position encoding, then we apply it, and then we just say so this is just so input plus positional encodings, and then it's basically X and X shape. I think that should work now. No. So what is it? What is not working? Too many indices for the array. Okay, so I think I just have to basically so this is a funky way to describe the signature of the of a function. So code for so that it adds p on top of x. So that's fine. Okay, so I just don't. Can you simplify this? So can. So NumPy's broadcasting rules allow us to add a 2D NumPy array to 3D NumPy. That's not the point. So X and PE have the same shape, and we just need to add them. That was my question. I think that's all we need to do. Why? Cannot we just do return? Like, doesn't this work? Yeah, I think that works, right? So, yeah, I have the feeling that's that is kind of fine. So 1010, that should be all right. Although, okay, so here it's definitely added something. The second element also, there's been some stuff. The third element, there's also been some shifting. And so can I print essentially x minus input IDs? Can you do that? And that should be exactly that should just be exactly the same like this one here. Okay. Yeah, but it works well. Whether it's doing the right operation or not, it's fine. But it works. It's adding stuff in. It's adding information in there, without changing the shape, which is what we want. Whether that information is the correct one or not, then there's something to debug later, I guess. But that's fine. So I think we can just basically almost call it a day for this session already. So this is adding it there. And now we will get into the multi-head attention layer. That's going to be the next step, which is going to be the more complicated piece, because essentially now what we're going to be doing is we're going to be calculating the attention numbers, and so that's gonna we will have. So what is these? Attention model num heads. So num heads is 4. So we will kind of have basically. So we don't care about these output after positional encoding. So we've been printing all this stuff. So output after multi-head attention. This is what we need. So I'm gonna go with this, and then the attention weights. This is what we need to interpret. And then I don't know. Then I guess what we can do is we can just try to see whether there's any way to visualize and to interpret these. But that's something we can ask Ghostwriter later. So that's good. At least we'll finish the positional encoding part. So we are now gonna head to the multi-head attention next. What is it that we're expecting though in here? So we're initializing these d-model num heads. We don't have here at all anything to do with max length. Okay, so here it's first of all is just trying to see whether we can really split these dimensions. Okay. And then it's gonna create, and then we have this split heads. So we're gonna be splitting things in here. We've got a batch size. I'm smelling this is definitely not gonna be correct right away, and then yeah, we'll see. So here we have, I don't know what these things are, split heads, QKV, then we're recalculating everything as like the scale to tension. The assert is failing, that's why it's failing. Maybe what happens if I just say 2? Well, let's just say 2. Maybe it just runs. No, okay. No, it's 2. Why? What happened? And line 44, attention weights. If it's 1. Yeah, okay, it doesn't work either. But it's why isn't it even printing this stuff? Oh no, it's printing this and that's it. I guess we want to print here and then print X and X. Okay. Yeah, but it doesn't. It seems like that's not even working. So we'll have to dig into this. But essentially, the outcome should be easy to interpret because it's supposed to kind of give us some weights of like how much attention each word with respect to each other has. So you know, it should be something that kind of can be intuitively read through. Let's see. Yeah. Thank you. Bye.